The Dunes Lake project, for those of you that haven't been out there yet, I think we had a tour out here a couple of years ago. It's a restoration project. The lake itself is a shallow water marl substrate system. And you can see that in these outer bays where you have that really whitish colored sediment, excuse me. Whereas the interior here is getting rather dark and organic-y. So this is where the problem is occurring, or has occurred. And basically this lake formed as the glaciers receded and the embayments started getting separated with the ridge swale networks as the beaches formed. And if you walk out there, you can see these ridges and swales quite clearly. So the project is a couple miles northeast of Sturgeon Bay. It's about a mile inland from Lake Michigan. As far as the watershed goes, I got to change something here on my screen. Sorry about that. I got a bar on top of my screen that's cutting everything off. All right, so anyways, it's about a 7,000 acre watershed, surface water watershed. It's rather dendritic in pattern. The one thing we did learn about this study is that there's a lot more groundwater contributing to the lake than we originally thought. So we did monitor at least 4 springs. We did quantify it. I don't have those numbers in front of me right now. But we also looked at, on the right side of my screen here is the agricultural land. The red dots are the agricultural sites, and the yellow area are the croplands. And let's see here, back in 2005 is really when we started seeing some of the effects on this system physically. So the gentleman in the upper left is Mike Grimm. He works for the Nature Conservancy, and he was leading a tour, part of a Festival of Nature thing that we do every year. And if you look in the bottom 2 pictures, you see these clumps of dead and dying algae in the creek, Geisel Creek, just before it gets into Dunes Lake. And this is really the problem that we're seeing. It's not a sediment of sand, silt, or clays. It's an accumulation of organic matters through vegetation from nutrients that are coming through the watershed. And in this slide, we have, one of the first slides is 1974. And if you look at the circles, it really shows where this ring of cattails has started to, basically enclose that inner lake from the outer bays. And so what's happening is that the nutrients coming down Geisel Creek are now being trapped in the center part of the lake, and it's really accelerating that eutrophication process. And it was filling in the inner lake. The outer bays, especially the one on the west side or the left side there, is really fed mainly by groundwater, and the vegetation there is really buffering the amount of nutrients coming into there. Whereas the bay on the east side, you can see it's kind of being half marlish and half muckish. Those are words. But there are some nutrients that are seeping through here as it goes downstream into Shivering Sands and eventually Lake Michigan. So I guess if you look at it, the groundwater flow is this way, and of course the surface water flow is this way. But if you look at some of these areas, and I'd say the distance here is probably about 150 feet across. So it's significant cattails. It's narrow leaf cattails. Those of you that haven't experienced it, they're about 10 feet tall. And you'll see some slides here in coming up that show some of the invasive work that we've done. Okay, so this is a kind of throughout the summer, we took some pictures back in 2013, and this is part of a phosphorus sampling protocol that we did, trying to figure out if phosphorus was impacting the lake. So in May, it looked pretty good. Vegetation was starting to come up. Late May, early June, same thing. And then mid-June, and we see this every year now as we get our first algae bloom. And it was amazing. You see this fluffy, bright green algae across the entire lake. And it's anywhere from 3 to 4 inches high as it's foaming up. When I came back a week later on June 20th, it was completely gone. However, the lily pads started coming in at that point in time. And by mid-July, I thought I was in the Everglades because it was hard to paddle through these things with all the vines on them. But then as the summer progressed, they died back down. And then, of course, by September, they were just about gone. So what you're seeing is the plant life really thriving on the phosphorus. And then once it's dead and decaying, it's adding to the muck layer in that inner lake. Okay, so the sources of nutrients, of course, we got non-point and agriculture. We have a point source. The Sebastopol Sanitary District serves Valmian Institute and has a primary and secondary wastewater ponds that discharge into Geisel Creek per their permit, basically 2 or 3 times a year, depending on the water volumes. The one thing that they did agree with us is to not discharge when they have a dry stream bed, because that would be discharging into surf or groundwaters. We also inventoried all the private septic systems in the watershed. And when we did the analysis for comparison, the non-point was about 77% of the phosphorus contribution, or about 360 pounds of phosphorus annually. Point sources were about 23%, and again, that's just the Sebastopol Sanitary District, so 108 pounds on average per year. And if you do the math, and there's several sources that cite this, but 1 pound of phosphorus can produce 300 to 500 pounds of algae, which annually is close to 93 tons of vegetation or algae. And it kind of looks like this. Or this. So when we started looking at the solutions for restoring this water body, of course, we had to deal with the agricultural sources. That was the main source. We've gotten all the sites into compliance now through the standards and prohibitions. The ongoing part is your nutrient management planning. Every year we have nutrient management plans submitted, and we do site visits. All the private sanitary systems were inspected several years ago. And of course, there's an annual or a schedule for looking at those as well. But currently all are in compliance. The WPDS permit for the Sebastopol Sanitary District, that's going to be renewed here in 2022. We're hoping that the DNR will install a little more restrictive requirements. The district also did a dredge out for the 2 ponds this year, so a lot of the deposits were finally removed out of there, so some of that legacy phosphorus is out of the system. And I guess just for note, it's the first time that they dredged that system in the 40 years it's been in existence. So then the final step was to remove the legacy phosphorus via hydraulic dredging in the lake. And as of Thanksgiving, that part of the project has been completed. So going back, this is the start of the pilot dredge in 2016, where we basically found out that we need to do a pilot project to figure out exact costs or more accurate costs and feasibility for dredging the entire system. So this is what the landscape looked like prior to building the dewatering basin. The same location and after. Basically, the dewatering or the dredge materials are going to be deposited here. And as the water comes around and settles out, it's going to go into here and then to another basin that's off the frame here, and then pump back into the project area. This is the dredge that they brought out during the pilot. It's the same one they used this last year as well. If you will take note to the spuds here in the back as to how tall they are. You'll see a picture here when that dredge is in operation as to, and it's part of moving the machinery through the water body, but it's also a way of anchoring it so that it can accurately dredge the materials. And when Greg Meisner from the Doyleland Preserve, he's one of the partners with this project. We were taking these pictures when the dredge arrived on the semi truck, and we were really wondering how they were going to get this thing off of there because they didn't have a ramp on the back of it or anything. basically, though, it took its hydraulic arms, it picked itself up, and the truck drove off. And then they had a bulldozer that brought the dredge back to the edge of the water body. And then the dredge basically used the front bucket and the hydraulic arms on both sides, basically to I don't know if waddle like a turtle is the correct way to say it, but they basically were able to push itself into the water and get into the project site. It was, for a first time dredging project, this is really interesting and outside of my comfort zone. And then with the pipe for dredging, the pipe had to be welded together. That's what this machine is right here. And it takes about 25 to 30 minutes to weld each piece together. And initially they would, use a skid steer to pull the pipe towards the lake. But in the end, they ended up pushing the pipe and having individuals steer the pipe through the cedar trees. So again, this was very interesting as to how they got this project underway, but these guys do this stuff for a living, so they knew what they were doing. So here's the pipe going into the East Bay. For those of you that were on our trip back in 17, the tour, this is where we came out to walk up and have lunch. So the inner lake is behind these cattails, but not as far as the wood line there. So this is the dredge in operation. Here's the spuds that I mentioned. So they're driven down, I think he said 10 to 12 feet is what he had. So there's 2 or 3 feet of muck that they're driving through. And then he said they felt more resistance, which was probably that marl and maybe even some sand. But for the most part, most of the times he was able to find bedrock and lock those in. However, he did find one spot where there was no bottom. Just a picture of the dredge head. We did have a little bit of issues with the lily pad roots, basically getting cut up and floating to the surface, but we were able to, and here's a bunch of these roots, we were able to suck those up at the end on a really windy day and put those in the dewatering basin as well. Here's a picture of a lily pad root. So it's kind of interesting when we came in to look at the pilot project, it looked like a bunch of dead carp floating all over the place. But in the end, we got it all out. So again, here's a picture of the dewatering basin for the pilot project. The previous pictures I took in the far corner. And again, this is the day after we wanted to get all those lily pad roots out of the system. This is the machine that they used during the pilot project only. We did not use it for the finish up. But basically, this system was pumping in some coagulants and some surfactants into the dredge water. And here's one of the chemicals that they used. I don't know what the name of it is offhand. But part of the project, we had to monitor the TSS going out of the system. And this is one of his sample ports where they're just seeing how the coagulants and surfactants are working. So within seconds, basically the water settled out to solids. And as far as visually goes, at the pump here, it looks a lot like liquid manure coming out of the pipe. But then as it went through the system, you could see this water started clarifying really quick, even before it went around the berm. So it kind of seemed kind of like magic that was going on in front of us, but I guess it's all science. And I don't know if I can get this to play or not, but let's see. So this is the discharge site during the pilot. And as you can see, that water is really, really clear. Okay, so this is a 2017 picture from the contractors that we had, Peterson Contractors Incorporated. And again, in the foreground here is that West Bay, the Marl Bay. This is Geisel Creek coming down into the lake. The pilot project was right here that we did in 2016. And this is just the path that the dredge took to get into the project area. These dead areas of dead vegetation, these are some of the areas that we treated for Phragmites and narrow leaf cattails. So we tried to get to the areas that were probably the better habitat and or what we could reach. Some of these areas like this, we tried to treat this on 2 occasions and not much for footing. So, and again, if you remember the slides before, this is all new cattails that grew in since 1974 as part of this restoration effort. Again, just another photo of the pilot project, straight down on it with the drone. Which brings in phase 2. Phase 2 started last year, 2020. We had a Wisconsin Coastal Management Program grant of $100,000 through this department, and Ducks Unlimited was able to also get a $700,000 plus grant from the Sustain Our Great Lakes program and Wisconsin Coastal Management and some other sources of donations and such. So our goal is to get about 18 acres of surface water and cattails dredged. We also wanted to restore the connectivity through the cattails, which had encircled that inner lake and really had restricted northern pike spawning habitat and abilities. We had estimated the project to complete at about 1.2 million. So we had about 820,000, I believe, and then we worked on some other funding sources to get the amount of money basically to complete it. One of the issues we had is that we could not dredge between March 1 and August 15th. So that basically leaves August 16th to freeze up for the equipment and for everything to work out. But of course, we had that limitation so that we'd be protecting the spawning fish and nesting birds in the area. So over 2020 and 2021, 2 falls, we were able to complete the project. This is a photo in the fall of 2020. It's a drone photo. This is with the dredge actively dredging. And so this is the pipe going back to the dewatering basin with the dredge materials. And Geisel Creek is going to come out on the bottom right here. The fish connectivity that we're going to put in is going to be right about here. And this is the second dewatering basin. So the first picture is basically a semi-wooded area that's being grubbed and cut out. The second picture on the right is the completed basin. Individual in the background is Kevin Sang. He's not the tallest individual in the world, but with his hands up, he's about 6.5 feet. So we're probably looking at a basin that at places is probably 10 feet deep. And as far as acreage, it's about 5 acres. The bottom left here is after, let's see, that's spring of 2021. So this has got the dredgings from 2020. And it didn't take long, and these sediments started to vegetate. And by the time we started dredging in, I think it was October or November here, some of this vegetation was 6 feet tall. On the upper ends, we had a lot of cottonwood and other grasses and a lot of cattails on the end, and then even open water on the far end here. But it was really amazing to see how quickly that stuff vegetated. So on the upper left, I believed is a photograph that Josh Martinez from Wisconsin DNR took, another partner with the project here. And I think this was July of 2015. And basically it shows the extent of the algae and the vegetation that's growing within the system. And if you look, again, we're really only seeing the problem in the inner lake and where the nutrients are starting to slide through or slip through the ring of cattails. We're really not seeing much for vegetative growth, which is typical of these low nutrient marl lakes. So we know that there's a legacy phosphorus issue here. And again, that was our goal, is to get some of that out of there. And what we did is we targeted the top 2 feet out of the 3 feet that we sampled. And I think that was 76% of the phosphorus that was in that profile. So we did the 2 feet here in the pilot in 2016. The photo down here is the aerial photographs for Door County the spring of 2021. So the pilot was here, and the dredging that they did shows up pretty clearly here. There were some areas that they didn't get to or finished up this year, but primarily they needed to finish up this area and work on some of the cattail infringement. We couldn't do it all the vegetation, just because we had a limit on the cubic yardage that we could take out, and also the cost. I mean, if we would have had another couple $100,000, we could have took some more material out if we amended the permits. And then this photo was taken just a couple weeks ago, so we were able to get some of this vegetation out in some of these pockets. We did dredge all the way up to here in the channel and got all this other material out. And again, this is the fish passage that we reestablished. And then in the background is Lake Michigan. So our partners, Fish and Wildlife, Coastal Management, Fund for Lake Michigan, Great Lakes Protection Fund. The Doorland Preserve property owners put a lot of money into this. Raybrook Foundation, Partners for Fish and Wildlife, and Sustain Our Great Lakes. So it's been really it's been a long project. It's been a successful project. It's been a lot of partners, a lot of coordination, and it's kind of hard to believe that it's done, other than we're going to have to do a lot of aquatic vegetation maintenance, and we're going to do a lot of follow-up water testing too, to see how well this actually turned out.
Hey Greg, can we ask a
Yes.
question?
You sure can, because I'm done.
Can you go back to that last slide that showed the water body before the funders? Yeah. So in the bottom right picture where you have where you talked about the fish passage, does that eventually open up all the way to Lake Michigan?
Yeah, it's the biggest problem was that this cattail ring here was getting so big and so massive that fish could get through during high water, but during low water they couldn't get back through. So in the spring the pike were coming up and they were spawning.
Okay.
A lot of these fish, when the fingerlings would come back down, they couldn't get out, and
Sure.
the birds had a heyday on them. The other thing that we did notice here, and I didn't mention in the presentation, is that we did some minnow trapping with some permits last year, before we started the secondary phase, and we caught some mud minnows and we caught some bullheads, but they all died. And we think what happened is that over the course of the night, the oxygen levels crashed, and the species that we caught may typically come up into the profile and sip air off the surface. So we're hoping that, too, that not only can they pass through, but they're not going to get trapped in here anymore.
Yeah. And then, man, this is so impressive. What a massive, massive project. Do you hope or have any goals to increase the dredging in the future? Do you want to try and get so many acres of open water restored, or do you feel like you've met the goal?
Yeah, I mean, for the most part, we got, we had 18 acres left, and really that 18 acres included about 50 feet of peripheral around the entire inner bay because of the cattail infringement. That peninsula, we tried to get a lot of that out, but it was such tough going with all the roots and such. And the reason why we tried spraying it for the last 2 years is so that we could, break down that root matter. The problem is that every contractor that went in there with the marsh master got stuck, and they were worried about their safety, so we kind of abandoned that. But basically it comes down to habitat and water depth. And I would say that we probably set the clock back about 100 years as far as, because we did have the sediments aged as far as with some isotopes and whatnot, and some algae groups, or plankton groups actually. And there is a full study on this on our website, but I'm mainly focusing on the restoration effort and how long it took to get to this point.
Mm-hmm. So did you say you opened up 18 acres, or the open area is 18 acres now?
Well, if we went back to, let's see, I don't know if I can go back to it, but if we went back to that 1974 photo or the 92 photo, The 92 photo had 20 acres of open water in that basin, that inner basin. So that was kind of our goal, is to get to that 20 acres with this.
Okay.
We probably got about the 18 and a half, almost 19 acres of open water again.
That's awesome. Congrats. What a huge project.
Greg, this is Ashley. If I can ask another question, I'm wondering about your settlement ponds that you have. Are you doing anything with the material that settled out of there? Or are you just leaving it in the wetlandish complex that is created now?
That's an excellent question, and it has a lot of different ways you can go with it. The first dewatering basin, most of that stuff we gave away to the town of Sevastopol. And this is a part of the project I didn't mention, but when you apply for grants, and I'll get to your question, when you apply for these grants, we learned a lot with some of the failures where we applied and did not get the funding. Probably the first one was you didn't do a pilot project and you don't have public access. So we did the pilot project, and we also put in a small parking lot for people to park their vehicles and then portage their boats down to Geisel Creek. That project was done on town property, which was part of an abandoned landfill. And this abandoned landfill had not been looked at or monitored for decades. So in the end, the town had to also make improvements out there, and part of it was a diversion of water and including a cap on top of it. So the first round of materials, a lot of that went to the town of Sevastopol to kind of lessen the costs of that capping or recapping or getting into compliance with an abandoned landfill. The second dewatering system, we have about 60,000 cubic yards of material in there. And we can either sell it, we can let it compact and then cover it back up with the berms, or the current plan right now is to shape it with a contractor. We can barter the materials for contractor work as long as we're not selling the material. And the goal is to have a small shallow water pond on the far end and put the rest into a prairie planting. So a contractor would take a lot of this organic material, blend it with topsoil and whatnot, since we have a shortage in the county, and then shape it to something that's a pollinator / prairie / wildlife area.
Thanks, Greg. That's interesting.